Hello. So our group 6, did cuisine prediction. The primary goal of this was to accurately predict the cultural cuisine of a given recipe based solely on the ingredients that it has. We also wanted to display the difference between particular cuisines using like charts and stuff, and provide statistics on the difference between the cuisines. So the data set we used, it splits the data into two typical sets, with the training data having 40,000 roughly ingredients, and the testing data having 10,000. The test data contains an ID for the dish and a list of ingredients, while the training data adds in cuisine, and you can see that on the right here. Um, this is the number of ingredients per recipe in the data set. So you can see along this bell curve, there are some outliers here up here, but on average, like it's roughly around 10. And this is what the data set looks like when we sort it by ID. Pretty standard stuff, and it shows the cuisine here as well. Um, yeah. So cuisine classification. By creating this model that predicts a cuisine, we can easily start to categorize and classify dishes based on their ingredients alone. This kind of model could create interesting cultural mashups of dishes and new genres of fusion food using this kind of AI. And I think that's pretty freaking cool, honestly. Um, Cuisine ingredient count average. So we can see that like Moroccan has on average, like they got 12 more ingredients. You know, that's nuts. And then Irish is around like 9 or so, and it's very pretty chart as well. So here, this code removes the special characters. This isn't necessary for our dataset because the dataset actually didn't like have any of these special characters. But I wanted to write this solely so we could just like practice it for the future. And here we remove the stop words as well. This is what our dataset looks like when it's printed out after this tokenization takes place. We further tokenize the ingredient list so we could call the fit function. This is an issue we were stuck on for quite some time. The fit function wouldn't allow the data set that we had to fit in because it needed to be in a matrix. And so by doing this, we fix that. So the first model that we used for the AI was the KNN model, K nearest neighbors. This was because it's pretty simple and it generally is pretty accurate for various things. And you can see here the most accurate version was after the 11th K value. The next one we used was the decision tree classifier. This was a good choice for the project because the prediction of lowest index in our data. Um, and the accuracy of this model was 0.88. And DTC was clearly the better choice in the end. And that's it. That's all, folks.